Hey, and welcome to another episode of 30 Minutes to Merge. I'm your host, Matt, aka Beard of EDU. And today I am going to be introducing a super awesome principal engineer, principal engineer at GitHub named Eileen. Oh man, I just had her last name and then I forgot it. Uchitelle, there it is. So a couple of things about my awesome guest today. So first and foremost, she will be discussing class variables in Ruby. Sorry. Hello.
Hi.
How's it going? So she's going to be discussing how class variables work in Ruby, as well as the implementation of the cache that they threw in 3.1, right?
Yep.
Awesome.
I hope you can see the right. I can't see my browser anymore. So
we're not
you
looking
can
at
see
your
my
browser
notes.
yet?
You have to. I
Okay.
have the wrong one shared, but I think I
Okay.
have the right one.
All right. Well, we'll see them in just a sec. So just really quickly, just to introduce you to everyone on the internet and some of the stuff that you're into. So you're a big fan of hiking, traveling, and photography. So maybe you travel and then hike and take photos at the same time. You've also got a Husky lab mix named Aria. And you're currently involved as a core maintainer of Ruby on Rails open source project, a maintainer of Rack, and every once in a while when you have time, you like to work on Ruby. Awesome.
Yep.
Well, thank you very much for joining us today. I'm not going to stay in your hair too much longer, so I hope you have a great presentation, and I'll be watching for any chat comments and throwing them your way as they come in.
Cool. All right, I guess we should get started. Hi, everybody. As mentioned, I'm Eileen Uchitelle, and you can find me anywhere online at the handle Eileen Codes. I've been a member of the Rails core team since 2017. The core team for Rails is similar to Ruby core. We both work to drive the future of our language or framework. On the core team, we plan releases, merge contributions, and build functionality to improve the framework in order to support applications as they grow. I work at GitHub, where I'm my principal software engineer. I work on improving the Rails framework and Ruby language so that we can continue to use them for the long haul. Our team at GitHub works to find areas where we can improve performance, add functionality, fix bugs, and really push the boundaries of what Rails and Ruby can do. In the past year, we've made many improvements to Ruby, including making the super method faster, fixing bugs, updating gems to support Ruby 3, sending pull requests to Shopify's widget, and of course, what we're here to talk about today, improving the performance of class variables. Earlier this year, I worked with Aaron Patterson from Shopify on adding a cache to class variables to make them faster. On the surface, adding a cache probably sounds like a relatively simple project. However, it took us probably about 6 months and a few different attempts to accomplish this because it turns out that class variables are incredibly complex in Ruby. Today, we're going to talk about how class variables work, what makes them complex, why they were slow, and how we made a cache to improve their performance. After diving into the technical details, we'll take a look at what we learned, how to handle trade-offs in open source, and lastly, why it's so important that we all work to make improvements to Ruby. Before we dive into Ruby's internals and how we improve performance, let's first take a look at what a CVAR is and how it works. A CVAR, or class variable, is a type of Ruby variable that is defined on the class level rather than the instance level. You're probably very familiar with instance variables if you write Ruby at all, but you're less likely to have worked directly with class variables. They're a bit difficult to reason about, and you'll often be told to avoid using them in application code. Literally every Ruby book recommends that you avoid them. Class variables are denoted by 2 @ signs instead of 1. In this class here, we have a setter for the class variable named CVAR, and we have a method to read that class variable. This all looks pretty simple, right? What can be so complex about class variables based on this example? Well, you see, class variables get a lot more complex once you start to look at how their inheritance works. To understand the complexity of that, let's first look at how instance variable inheritance works. Here we have 2 classes. Class dog has an initializer for the name with the value aria, and owner with the value Eileen. Puppy inherits from dog and sets the value of name to Sansa, but does not set owner. When we read the class variables in Ruby, we can see that the IVARs are isolated to their instance. While puppy inherits from dog, puppy doesn't automatically inherit its initialized instance variables. We can see here that the name on dog is set to aria, owner is set to Eileen, name on puppy instance is set to Sansa, and owner returns nil. Instance variables are bound to the current self, which in this case is the instance of the class dog or puppy. The instance variables on dog are isolated from the instance variables on puppy. Initializing a dog instance doesn't change puppy, and initializing a puppy instance doesn't change dog's variables. If you've been writing Ruby for a bit, you're likely already familiar with how instance variables work, as it's one of the first things that we learn in Ruby. The inheritance model is straightforward when it comes to instance variables. Class variables, on the other hand, behave very differently in regards to inheritance, which can cause confusion about how to use them properly. Let's take a similar example, but this time with class variables. In this example, dog has a name class variable set to aria and an owner class variable set to Eileen. Puppy inherits from dog and sets the name class variable to Sansa. Now let's see what happens when we actually read these class variables. Here we can see that dog owner is Eileen and puppy owner is also Eileen. Remember, with instance variables, puppy owner was nil, so this is already a little different, but not entirely odd. But let's see what name on dog is. Wait, dog name is set to Sansa? Shouldn't it be aria? And puppy name is also set to Sansa. How can that be? Isn't that a bug? Why would both classes return puppy's value for the name class variable? Well, this might look like a bug, but it's actually how class variables are supposed to work. CVARs are shared among their descendants. Think of class variables as global. They can only have one value in the inheritance chain, and the last one to set the class variable wins. Every time you write or read a class variable, Ruby will walk the entire inheritance chain all the way up to basic object looking for the topmost class in the chain that sets that same CVAR. So if name is set on both puppy and dog, the actual value of name will be stored on dog, which is the parent of puppy. Dog will also store the value of owner. When puppy sets name, Aria will be overwritten on dog with the value Sansa, because the last class in the chain to set the class variable wins, even though that value is stored in the dog class. The information for the class variable name is stored in a hash table, which is accessed on dog, since dog is the topmost class that also has a setter for name. Fun fact, class variables and instance variables are stored in the same hash table structure in Ruby. This is possible because the double @ sign is not a valid instance variable name, so IVARs and CVARs will never clash. You might be looking at this and thinking, well, if the hash table is stored on the topmost class, why can't we just stop at dog? Why does Ruby need to keep going all the way up the chain to basic object every time a class variable is written or read? Well, the reason is that Ruby needs to do this to handle what's called the CVAR overtaken case. Since you can reopen classes in Ruby or mix in modules, Ruby can't be sure there isn't already a class variable with the same key set. So every time a class is called, Ruby has to check the entire chain for an existing hash table, and if it finds one, we'll raise an error. Let's look at an example. Here we have dog defined without a class variable and puppy class that defines a name. In this case, the class variable hash table is stored on puppy because dog did not set a name class variable. We then reopen the dog class and define a name class variable in that new class. When our code tries to read the name class variable on puppy, it will raise an error that says class variable name of puppy was overtaken by dog. What's happening here is that when the name class variable is set on dog, the hash table that was stored on puppy gets overtaken because the class was reopened. The class variable needs to be stored on the highest ancestor that sets the class variable. So when puppy name is called, the hash table that was stored there is effectively broken because we reopened the dog class and set the same class variable there. As you can see, class variable inheritance is incredibly complex, which is one of the reasons that it's a very disliked feature by Rubyists. Now that you understand how inheritance and overtaken work for class variables, you're probably not very surprised that the overtaken check means that class variables can be pretty slow. In fact, the deeper the inheritance chain, the slower it will be to write and read class variables. So if you have 100 classes in your inheritance chain, Ruby will need to walk all 100 classes plus the ones up to basic object for every single class variable that you access. Let's take a look at some benchmarks to see how slow it really is. Here we have a script that generates a list of letters that we can use for module names. Class 1 includes one module. Then we have a second class called 30, which includes 30 modules, and a third class that includes 100 modules. In this example, we're using the modules instead of classes, but the behavior in Ruby is the same as the class inheritance. Then our benchmark reads the CVAR getter from each of our classes to demonstrate that when the inheritance chain is deeper, class variables get slower. Want to see the numbers? Well, in Ruby 3 at the time, including 30 modules with a class variable was 2.8 times slower than including one module, and including 100 modules was 8.5 times slower than including one module. 8.5 times slower. That's a pretty significant difference. It's clear that you don't have to worry much about class variable performance if you only have one or two classes in your inheritance chain. But if you have 100 modules with a class variable, it's potentially affecting your application performance. But how often do we have deep enough inheritance chains that are using class variables? When working on improving performance, it's important to realize that micro benchmarks that show an improvement might not translate into meaningful performance improvements in your application or library. So once we knew how slow class variables were, the question became, how often are class variables used, and how often is the inheritance chain deep enough on a class variable, deep enough to make a difference on class variable performance? It's not going to be worth improving performance of class variables if nobody ever uses them. And while you may not use class variables in your application code, you might be surprised to find out that Rails uses class variables extensively for application configuration. One of the probably the most well-known ones is active record-based configurations. This class variable stores all of the database configurations that your application needs to connect to. In addition, anytime that you see matter accessor in Rails, that's actually a feature of Rails that under the hood is creating a class variable. And it wouldn't be a big deal that Rails uses class variables a lot if most Rails libraries had a small inheritance chain. But when we look at the ancestors of a few key classes, we can see that Rails inheritance chains are often quite deep. In a vanilla Rails application, active record has 73 ancestors, active controller has 71, and active job has 29. And all three of these classes use class variables. This means that if you're using Rails, the performance of class variables is likely affecting your application performance in a very real way. In order to address this, Aaron Patterson and I set out to build a cache for class variables. When Aaron and I first started working on this, we didn't realize how complex and nuanced class variables were, so it took us a very long time to figure out a cache strategy that worked. While it was a difficult project that took us about 6 months, we wanted to pursue it because we knew that class variables were slow and that their slowness affected every single application. If we can make class variables faster, we can make Ruby faster. If we can make Ruby faster, we can make Rails faster, and then we can make our own applications faster and your application faster. This was an opportunity to improve the performance of every single code base that uses class variables. As we saw earlier, class variables are stored in a hash table on the highest class that set the CVAR. So it made sense for us to store a hash table for the cache next to the class variable hash table as well. Then we could lean on all of the existing class variable code and handle creating and busting the cache alongside it. The cache hash table holds the class variable name, which points to an inline cache. The inline cache has a pointer to dog that tracks a value called global CVAR state. The cache is stored in the topmost class, so when puppy needs to find its class variable, the cache will be created by dog. The first time we read or write a class variable, Ruby will still walk all the way up the inheritance chain looking for the topmost class that has a setter for the named class variable. While doing this, an inline cache is created, and that cache is stored in the bytecode so that puppy can access it when needed. The next time we read or write that class variable, Ruby will use the cache to do the lookup instead of walking up the chain. For example, when we call puppy name in our application, Ruby will find the global CVAR state from the cache and compare it to the get global CVAR state value. If they match, that means that we've seen this class variable before. The cache then returns the dog class, which informs Ruby where to look up the class variable hash table. And then the value Sansa will be returned from the dog class's hash table. This allows Ruby to entirely skip walking up the inheritance tree once the cache is created. In the case of Overtaken, global CVAR state would have a different value than get global CVAR state, and the cache would be ignored. If the values are different, Ruby will walk the ancestor chain to build a new cache. And that's basically it. As you can see, the overall cache ended up with a relatively simple design. We're not going to look at any C code because it's frankly not that interesting. But if you're interested, you can find the PR on GitHub. While the cache ended up with a simple design, it took us a long time to get a good handle on how class variables work in Ruby. The majority of our time was spent tracing code to try to figure out the best way to cache class variables without breaking the inheritance or overtaken behavior. When we were done adding the cache, it was time to run some benchmarks to see if our cache was faster. Remember, just because you think you improved performance doesn't mean you actually did. So it's important to always benchmark your changes. Let's revisit that benchmark from earlier that showed that including 100 modules that read a CVAR was 8.5 times slower than including one module. When running the same benchmark on our branch that added the cache, we saw that we completely eliminated the progressive growth that occurred as more classes were added to the inheritance chain. Now including one module with a class variable that has the same performance, including one module with a class variable has the same performance as including 100 modules with a class variable. While this benchmark showed a massive improvement in performance, it's still considered a micro benchmark, which means that it doesn't represent real-world scenarios. We needed a benchmark that was more representative of a real application in production. So we decided to measure the performance with Rails Bench, which is a Rails application that can be used to measure requests per second in a slightly more production-like environment. It's not the same as running it in our application on production hosts, but it can tell us a lot more than a micro benchmark. With Rails Bench, we saw that Rails 6.1 without a class variable cache could perform 615 requests per second. Then we did the same measurement using our class variable cache branch, and we found that we could perform 657 requests per second. With the cache, we get 42 more requests per second, which works out to a little more than 6% improvement in request times. These benchmarks demonstrated that the class variable cache is faster not just in micro benchmark scenarios, but will have a real impact on application performance as well. Through this work, Aaron and I learned a ton. At first, adding a cache to class variables seemed like a relatively simple task when we first started working on this project. But as I mentioned earlier, it took us about 6 months to actually get something working that we were confident was, well, not full of bugs. I remember at one point we thought we were ready to open the PR for the cache, and Aaron had a dream that we had a bug in the overtaken behavior, and it turned out that he was right. The complexity of class variable inheritance was why this change was so difficult. When we finally got the bug fixed, test passing, diagrams made, and we were confident in our changes, it was time to open the pull request and a feature request issue. After some discussion on the issue, I started to get nervous because it became clear the Ruby team wasn't sure they wanted to merge the feature. Of course, everyone appreciated the work that Aaron and I had done, but like I said, class variables are very complex, and by adding this cache, we increased complexity. Eventually, we did get it merged, but I want to take some time to dive into what concerns the core team had and how we navigated negotiating getting this change merged. Fundamentally, every change in open source has trade-offs. Actually, let's be real, every change in code everywhere has trade-offs. I'm sure you've experienced this at work in your own job, trying to decide whether it's worth the risk of fixing that technical debt or just ignore it and build your feature. Maybe you opt to add complexity because you think you'll get back to it later and fix it, but we all know you never do. Maybe you decide to not remove that out-of-date gem because you don't have time. Maybe you write a monkey patch in your application instead of sending an upstream patch because you don't want to wait for a release. Every day we weigh trade-offs regarding complexity against one another when making a change to our code base. Open source maintainers need to weigh trade-offs too of whether a change is worth it or not. To Aaron and I, adding a cache seemed like a clear win. CVARs are slow, we made CVARs fast, so objectively adding a cache is a net win, right? What trade-offs could there possibly be when we fix a performance issue in Ruby? When you have a feature that is as complex as class variables, any change, even a small change, has trade-offs that maintainers need to consider. The first trade-off the core team was concerned about was that our change increased complexity of class variables. As you saw today, CVARs are already so complex. So by adding something even as simple as a cache, we made them even more complex. In addition to the inheritance and overtaking complexity, we've now introduced the complexity of creating, updating, and busting an inline cache. When the cache was done, it seemed simple to us, but the process to get there demonstrated that it's not as straightforward as it looked. To accomplish adding a cache, we had to add a second hash table, track every time we write a new CVAR, and ensure that the cache behaved properly when class variables are overtaken. Class variable behavior around inheritance means that there's a lot of places we could get it wrong. We had to be absolutely sure that we covered every case for when a new class variable can be set in Ruby code. Another concern the core team had was that we were accidentally going to encourage more people to use class variables by making them faster. As I mentioned earlier, it's not a well-liked feature of Ruby, not even by the language maintainers. Some people consider them so confusing to use correctly, they might as well be deprecated. The concern was if we made class variables faster, then we'd accidentally encourage applications and libraries to use them more. Since most Ruby programmers aren't aware of the intricacies and complexity of class variable behavior, encouraging more usage might lead to bug reports on the issues tracker or other efforts to make them better. If we keep making them more useful, they're a lot harder to deprecate in the future. Lastly, by adding a cache to class variables, we also increase the maintenance burden for the core team. What if a new case for inheritance is added and we miss clearing the cache? What if there's a bug in the existing code and now we're hiding it? What if we're caching the wrong information in a specialized edge case? What are the risks of this change to existing applications? For perspective, consider your own application at work or a library you maintain. Is there a feature or part of the code base you know better than anyone else? What if someone came along and changed that code? How would you feel if you knew it was probably a net gain, but now you're worried that you no longer understand all of the moving parts? I've experienced this a lot as a Rails maintainer. I want contributions, but I don't want to introduce changes I don't understand, because once it's merged, I'm now responsible for that new code. I completely understood where the core team was coming from, even though I felt like adding a cache was a net win. Once we understood the concerns of the core team, we needed to convince them that this change was worth it. Negotiating whether a change should be merged is a tough thing to do, but it's an important skill for contributing to open source. First, we pointed out that class variables aren't deprecated and are unlikely to be removed from the language, even if they're an unpopular feature. While they are quite complex and have strange semantics, class variables are the only available feature to use in certain cases. And there isn't a better alternative when you really need the inheritance behavior of class variables. For example, in Rails, the database configurations have to be a class variable because we never want a subclass of active record to have a different value than the parent class. In the case of configurations, it is a global, and there can only be one value. Using an instance variable would break that contract that active record relies on. In addition, the benchmarks we provided showed real-world impact to applications. It wouldn't have been convincing if all we had were micro benchmarks that showed an improvement to class variables in isolation. By doing the work to get a benchmark that showed improvements to request times in Rails, we were able to show that the cache was effective in making request times 6 to 7% faster. The benchmarks are compelling because they demonstrate real-world improvements, making the complexity worth taking on. Lastly, one of the net benefits of making this type of change to Ruby is that applications can get a performance boost without changing their code. All they need to do is upgrade. This is compelling because if Ruby is slower, thus applications upgrade. But if Ruby is faster, more applications upgrade. Also, it's more enticing to upgrade if you don't need to change your application to get free performance improvements. With these 3 points, we had convinced Matt and the Ruby core team that it was worth trying the class variable cache in Ruby, and it was merged in June. It'll be released in Ruby 3.1, which the preview is already out if you want to try it. Negotiation isn't about being agreeable or acquiescing to what a maintainer wants. It's about understanding the concerns and working to demonstrate the value of your change. In a negotiation, take time to understand the concerns of the maintainers because they end up maintaining the code. Take time to consider how you can make the change less risky or complex. Think about how you can prove the change is a net gain that offsets risk. Be willing to do the work to advocate for your change and provide evidence that any added maintenance or complexity is worth the cost. If you're a Rubyist, I hope that learning about our journey to add a cache to class variables has inspired you to contribute to Ruby in the future. I want us to contribute more to Ruby because this is how we maintain a healthy ecosystem for years to come. If you're at all worried about Ruby becoming less popular or dying, then the best way to prevent that is for us, everyone here, to start contributing to Ruby. Let's work on making Ruby better so that applications can not only run on Ruby, but thrive on Ruby as well. I know firsthand that contributing to open source is scary, so I want to take a little bit of time to talk about how you can start working on Ruby too. The first thing that you can do is learn C. I'm not a C expert, so while I was writing this talk, I had to go back and reread the cache like 800 times to figure out how it worked. In this case, I wouldn't even really call myself a beginner C programmer. I'm more like a C tourist, visiting it when I want to work on making Ruby better. However, learning C is going to make contributing to Ruby a lot easier because, well, Ruby is written in C. So the more C you know, the easier it will be to understand those internals. In addition to learning C, you're going to want to get an understanding of how Ruby is designed. For that, I recommend Ruby Under a Microscope by Pat Shaughnessy. This book dives into the design of Ruby's parser and VM and other areas that make the language unique. While the book was written in 2013 and some of Ruby's internals have changed since then, it's still an invaluable resource for understanding how Ruby was designed. And the fastest way to start contributing to Ruby is to start contributing. That sounds kind of simplistic, but it's also true. You can't contribute to Ruby by thinking about it. I get that making changes to a programming language used by hundreds of thousands of applications can be overwhelming, but you don't need to go implement a new JIT to contribute to Ruby. You can make small changes like documentation updates, fixing bugs on the issues tracker, and benchmarking and improving performance. I've heard people say like Ruby's slow because it's Ruby, but if there's something that's slow about Ruby, it's because no one tried making it faster yet. The person that can make it faster might just be you. So I hope this talk has inspired you to contribute to Ruby and look for ways that you can make the language better. When we contribute to Ruby and make the language faster, cleaner, or add features, we're making Ruby better for everyone. But we're also making Ruby better for ourselves. Every change to Ruby is for everyone in this room, for everyone at home, for you, and for me. Contributing to Ruby isn't charity, and it's not a donation to the community. I don't do it for fun. Well, it is fun, but I contribute to Ruby so that I can continue to thrive as a language. I do it so GitHub can run on Ruby for 5, 10, 15, 100 years. I do it so Shopify can run on Ruby for 100 years. I do it so your application and your application and your application can run on Ruby for 100 years. And I want you to contribute to Ruby for the same reason, to ensure that it can support and scale and grow our applications for years to come. Ruby can't disappear if we don't let it, and Ruby can't go anywhere if we're actively working on making it better. So let's go make Ruby better together. Thank you.
That was awesome. Thank you so much. Wow, that was like a huge deep dive too. As someone who doesn't really mess with Ruby, I learned a whole bunch. So I've got a couple comments that I want to throw your way. Seems okay. Towards the end of your presentation, Cedric on YouTube threw in a bunch of comments. So one of them being that they learned that the difference between class variables in Python and Ruby is that in Python they can class variables can be changed by subclasses, while in Ruby they can't. So I didn't know if you had any comments there, or maybe you don't, and that's okay.
Well, they can be changed by subclasses, but it's still a global. So like if a subclass changes it, then all of them change. So they can't have different values, which is like what I showed with puppy and dog. So puppy inherits from dog. Puppy's a subclass of dog. Change the value of name to Sansa, but dog can't have a different value. They end up with the same value because there's only one place to store the class variable. But I'm not familiar enough with Python to tell you what the difference is.
Okay. All right. And when you were talking about ways to contribute to the Rails or the Ruby project, and mentioning learning C, they commented to also potentially learn Rust. Any thoughts?
I don't know. I don't know Rust, and
Okay.
Ruby's not written in Rust, so I don't know if that's going to be. It might be helpful for understanding some of the, lower level language, but since Ruby isn't written in Rust, it's not going to. It might help understand C better, but you still have to write C.
Okay.
Yeah.
Yeah, that definitely makes sense. And no worries, Cedric. I see you just said sorry. Not a problem. It's always good to get comments and then have people have the opportunity to, kind of talk to it. And then I guess they started looking into Svelte for speeding something up. Are you familiar with Svelte at all? And if not,
no.
C of the web kind of is what is the clarification there.
No, I haven't spent any time looking at.
Okay.
Svelte.
Not a problem. And then we have another question that just got thrown in. Can you make optional static typing a thing in Ruby now?
I'm not on the Ruby core team, so I personally don't get to make decisions about that. I am not a fan of static typing, so there is some work on static typing. I don't know how far along it is, and I'm pretty sure it's optional in Ruby, but I haven't actually played with it because I don't like static typing.
Fair enough. Well, I appreciate all the comments from the community. That's been great. It's always awesome to be able to ask some questions from our guests. But yeah, thanks again for showing up. That was awesome. I really appreciate your time, and I hopefully everyone else does as well. If people are celebrating the Thanksgiving holiday, I hope you have a great Thanksgiving holiday. And yeah, thanks again for joining us on a 30 Minutes to Merge. We'll see you next month. And yeah, have a wonderful one and have a great day.
Thanks, everybody. You can also find me on Twitter. I will answer things there if you have more questions. Eileen Codes. That's where I am everywhere. So.
Well, that makes it easy.
Yeah.